Hello and welcome to MATLAB course. This is Salim. In this video, I am going to talk about the arithmetic operation between scalar, vector, and matrix in MATLAB. So we need to understand what is the meaning of arithmetic operation, and let me remind you about the scalar, vector, and matrix definition. Let's start. First of all, as we mentioned before, all MATLAB variables are array, and this array will have a special name based on their dimension. For example, if this array have only one element, like one number, for example, x equals 5, in that sense, it's called scalar. And if the data is arranged in one row, in one column, it will be vector. So row vector or a column vector. If the data is arranged in several rows and several columns, it will be 2D array, or we called matrix. And if the data is have several rows, several columns, and also several layers, for example, 3 or 4, or etc., it will have like the multi-dimensional array. It will be array, and sometimes we call matrix. And in this course, we mainly focus on the scalar, vectors, and the 2D matrix. And for the arithmetic operation, we meant with that the addition or the plus or subtraction, minus, multiplication, and then division, and then the power. And in some cases, we need to put the dot or the period before the arithmetic operation. For example, dot plus, dot minus, dot multiplication, dot division, dot power. And the reason for that, because we need to execute it element by element operation, as I'm going to explain later. And in this video, I'm going to talk about the arithmetic operation between scalar and vector. It means one number with row vector or a column vector, or scalar to matrix, so one number with matrix, or vector to vector, which means row vector to row vector or column vector to column vector, and matrix to matrix, which means several rows and columns to several rows and columns, or vector and matrix as we saw here. And please note that I highlighted in red the places which you should use the dot. And if you notice, you can see that in the case of the plus and minus, for all the cases, in general, we don't need to put the period or dot. While in the case of in the power, we should use the dot in all the cases. While in the case of the multiplication and division, in some cases, we should use the period and sometimes not. In the scalar case, we don't need, but in the other case, we need. Let me explain. Let's start with the case of arithmetic operation between scalar and vector. It means one number with one rows or one columns of data. For example, if we start with this example, which say a, which is the variables, it's containing like several numbers in one row, so it is row vector with a value a1, a2, a3, and b variables, which is a scalar because it have only one value, is b small. So if we say a plus b, it means that b will be added to every element on a. So b plus a1, b plus a2, b plus a3 here. So a1 plus b, a2 plus b, a3 plus b. Similarly, if we say a minus b, it means that it will be a1 minus b, a2 minus b, a3 minus b. So every element in a, we remove the value of b, or we subtracted the value of b. And if we say a multiplied to b, so it will be a1 multiplied to b, a2 multiplied to b, a3 multiplied to b. And if we say a divided by b, so it will be a1 divided by b, a2 divided by b, a3 divided by b. And in this case, I highlighted in red because this is the new. If we need to raise every element in a to the power b, so in that sense, we should write a dot and then the caret symbol and then put b. So it will be a1 to the power b, a2 to the power b, a3 to the power b. And please note that if you didn't use the dot or the period before the power, it will give an error. Let's check the following example. For example, in this example, we have A with 3 elements, A, 2, 4, 6. This is row vector. And we have Y with a value of 3. If we said X plus B, it means that every element in A will be added to the value of B. So it will be 2 plus 3, it will be 5. And then 4 plus 3, it will be 7. And then 6 plus 3, it will be 9. And if we say X minus Y, it means that X, every element in X will be minus Y. So 2 minus 3, it will be minus 1. 4 minus 3, it's 1. 6 minus 3, it's 3. And if we say X multiplied to Y, so every element in X, 2 multiplied to 3, it is 6. And then 4 multiplied to 3, it's 12. And then 6 multiplied to 3, it's 18. And then X divided by Y, so 2 divided by 3, it will be 0.667. And then 4 divided by 3, it's 1.33. And 6 divided by 3, it will be 2. In the case of the power, we should use X dot to the power Y. In that sense, it will be 2 to the power 3, it will be 8. And then 4 to the power 3, it will be 64. And then 6 to the power 3, it will be 260. Let's practice. In this practice, we have two questions. A, for the function y equal to x squared minus 3x plus 2. So estimate the value of y for the x equal 5. It's very easy. So we can say y is equal to 5 to the power 2 minus 3 multiplied to 5 plus 2. 5 to the power 2 is 25. 3 multiplied to 5 is 15 plus 2. It means that this is 10 plus 2, it will be 12. So the output should be 12. This is if we have only if the x is scalar. But suppose that for the next example, they ask us for the function, same function, which is y equal to x squared minus 3x plus 2, estimate the value of y for the following value of x using element by element operation. It means that this different value of x, we need to estimate what will be the value of y for each value of x. For example, if the value of x is 1, so the y should be 1 to the power 2 minus 3 multiplied to 1 plus 2. And then in the value of 5, we said y equal to 5 to the power 2 minus 3 multiplied to 5 plus 2, etc. So we should repeat again and again for every element the same operation. This is we called element by element operation. And if we check, this is for every element, this kind of element by element, and we raise that this element to the power, so we should use dot, and then multiply this element to some number, so we don't need to use dot, and then add some number to that. Let's check that in MATLAB. I have MATLAB, and as we know, it's easy to use the live script. So if I open the live script, click open, and then go here to download, and then select this one and click open. I have the live script, and I prefer to have the live script maximized, so I will change the layout. From the layout, I created the customized layout. You don't need to care about that. But in this layout, only the live script is shown. The workspace is kind of minimized. The command history is minimized. The command window is minimized. And the current folder is minimized. So I have the live script now. And in the live script, we have the first example in which we say that x is equal to 5. And then we defined y. So in that sense, y is equal to x squared. So we can say x to the power 2. And then minus 3x, so we can write 3 multiplied to x and then plus 2. And then run the script, in the live script, run the section. We can find that x is equal to 5 and y is equal to 12. We already estimate that. And for the second question, for a series of x, so we need to define x, so we can say x is equal to square brackets and define 1 space, 5 space, 9 space, 13 space, and 17. Of course, this is the easiest way, and if we check, we can find there is a relation. 1 plus 4 is 5, 4 plus 5, 5 plus 4 is 9, 9 plus 4 is 13, 13 plus 4 is 17. So we can also define x as like the 1 with a spacing 4 and then reach 17. And also we can use the line space. We can say x is equal to, and then we can line space, and then we can define the start is 1 and the end is 17, and the total element is 1, 2, 3, 4, 5. We have 5 elements, and let's run the section to check. We have 3 value of x. All the 3 should be the same. Please use any of these. Let me comment. I mean the 2 I don't need, but all the 3 will give the same result. We have the x and we need to estimate the y. We are going to take the same equation because this is the same. But we have error now. What is the error? Let me run with the error first. Run the section. And he mentioned here for the error, you use the power. And we need to estimate that element by element wise. So in that sense, we should use dot for the power. As we mentioned, because the x, it is kind of not element, it's kind of a vector. And we need to perform a vector operation. So for each element, we need to repeat and repeat again. In that sense, we should dot pot. And then run the section. Yes, for example, in the case of 5, we estimated here. In the case of 5, the output should be 12. So it should be all the results, it should be okay. Of course, you can check using the pencil and paper. So this is finished. Let's go back and start again the presentation. This is the output. If you check, of course, we have the same output. And let's start the second section. In the second part, we need to consider the arithmetic operation between the scalar and the matrix. So we have only one number with a series of rows and columns. And let's consider this example. In this example, we have A, which is 2 rows, 3 columns. The element is A11, A12, A13, and then A21, A22, A23. And the B is a variable scalar with a value of B small. So if we say A plus B, it means that B will be added for every element in A. So here we can check that B added for every element in A because this is kind of adding scalar to the matrix. And similarly, if we write A minus B, so the B will be subtracted from every element of A. So A11 minus B, A12 minus B, etc. So all the elements will like have the same things. And for the A multiplied to B, it is the same. So the B will be multiplied for every element of A. So A1n multiplied to B, A12 multiplied to B, etc. All the rows, all the columns. For the A divided by B, same. So every element of A will be divided to B. So we will have A11 divided by B, A12 divided by B, etc. All the elements here. For the power, if we need to raise every element of A to the power B, we should use here the dot or the period before that power. So if we write A dot to the power B, in that sense we will have A11 to the power B, A12 to the power B, etc. All the elements will be like that. And again, if we use the power without the period, it will have an error. Let's check this example. In this example, X, it is 2 rows and 3 columns. So we defined 1, 3, 5 semicolons. So this means the start, the second row, and then 2, 4, and 6. So in that sense, we will have the X 1, 3, 5, 2, 4, 6, and we have the Y, it is scalar with a value of 3. And if we say here X plus Y, so every element in x will be added to y. So 1 plus 3, it will be 4. 3 plus 3, it will be 6. 5 plus 3, it will be 8. And then 2 plus 3, it will be 5. And then 4 plus 3, it will be 7. And then 6 plus 3, it will be 9. And again, if we say x minus y, so the value of y, which is 3, will be removed or subtracted from every element of every value of of x. So it would be x like that, like the first value 1. 1 minus 3, it would be minus 2. 3 minus 3, it would be 0. 5 minus 3, it would be 2, etc. So we will repeat for all the elements. Similarly, it's exactly the same if we say x multiplied to y. So we will multiply every element of a to the in x to the y. So like 1 multiplied to 3, it will be 3. And then 3 multiplied to 3, it will be 9. And then 5 multiplied to 3, it will be 15. And then 2 multiplied to 3, it will be 6, etc. And for the division, if we say x divided by y, so it will be 1 divided by 3, 0.33. 3 divided by 3, it will be 1. And then 5 divided by 3, it will be 1.67. And then 2 divided by 3, it will be 0.667. And 4 divided by 3, it's 1.33. And 6 divided by 3, it will be 2. For the power case, as we mentioned, we should use the period. And then we can say this is 1 to the power 3. 1 to any power, it's 1. And then 3 to the power 3, it will be 27, etc. for all the elements. Let's check the same example before, but instead of having the scalar or a vector, now we have a matrix. Let's go to our script here. And for the function y is equal to x squared minus 3x plus 2 for this element. Let's define that x is equal to, and then square brackets, and the first row 3 space 5 space 1, and then 2, and then semicolon, and then 9, 0, 7, and 8. And we have x now, we need to define y. We can take the y as it is here and put it here. Of course, this time it is correct because we use the power for the power. So we have x to the power 2, so every element in these x will be raised to the power 2, but we should use the period, and then every element here will be multiplied to 3, and every element here will be added to 2. So it will be very easy, straightforward. Just run the section and we will have the output here. Of course, if you need to check one element, if for example, when the value was 5 here, it gives 12, it is the same answer when we use a scalar. So we can check, by that we can check how will be our answer if we change it one value. Let's go back to the presentation, and we have here the output. And let's go to the next section. In the next section, we are going to consider the case where we have a row vector multiplied to row vector or column vector multiplied to column vector. Let's consider the example for the row vector, which is exactly the same for the column vector. But there are very important note here. To do the arithmetic operation between two vectors, they should have exactly the same shape. It means that it should be same number of rows or same number of columns. It means it's same number of size. For example, we consider here A, it is row vector with 3 elements, A1, A2, A3, and B is a row vector with element P1, P2, P3. So if we say A plus B, it means that A1 plus P1, A2 plus P2, A3 plus P3. So we can say here, A plus B, it's A1 plus P1, A2 plus P2, A3 plus P3. And similarly, if we say A minus B, so it will be A1 minus P1, A2 minus P2, A3 minus P3. So it's element by element wise. So we consider the first element here was the first element here, the second element here was the second element here, the third element here was the third element here. For multiplication, it's exactly the same, but we should put the dot here in that time because we need to do the multiplication with the element wise. If we don't use the dot, it will give an output in some cases, but it will have a different meaning. You will learn that, for example, in the mathematics class from the next semester. If we say A dot multiplied to B, it will be, for example, A1 multiplied to B1, it's the first element multiplied to first element, second A2 multiplied to B2, A3 multiplied to B3. And for the division, we should A and dot divided by B, so it will be A1 divided by B1, A2 divided by B1 by B2, A3 divided by B3. In the case of the power, A dot to the power B, it will be A raised to the power B, A2 to the power B, A3 to the power B3. Okay, let's consider this example. In this example, the x is a row vector with a value 3, 5, 7, and 9. And the y is a row vector also with the same size, which means 4 elements with 2, 4, 6, 8. If we just say x plus y, so in this case, every element in x will be added to every element to y. So 3 plus 2 is 5, 5 plus 4 is 9, 7 plus 6 is 13, 9 plus 8 is 17. And similarly, if we say x minus y, so x, the first element 3 minus 2, it will be 1, and 5 minus 4, it is 1, 7 minus 6 is 1, and then 9 minus 8, it is 1. For the multiplication, we should use the dot multiply because in the vector case, we should use the dot to have the element by element. So 3 multiplied to 2 is 6, and then 5 multiplied to 4 is 20, and 6 multiplied to 7 is 42, and 8 multiplied to 9, it is 72. It is the same for like the division, similar to the multiplication. We should use the dot divide, and then it will be 3 divided by 2, it's 1.5, 5 divided by 4, it's 1.25, etc. to the end of that. In the power case, we should use the dot power. This is, in all cases, we should use dot with the power. So 3 to the power 2, it is 9, and 5 to the power 4, it is 625, etc. to the other elements. And let's practice. And for this example, so we have two vectors, v and u. The v's element is 3 minus 1, 2, and the y is 6, 4 minus 3. The first requirement is by hand, using the pencil and paper, write what will be displayed in the following if we use the following command. So for example, if we have v plus u, in that sense, we have the v, it is 3 minus 1, 2, and u, it is having 6, 4 minus 3. V plus u is mean every element in v plus every element u, so 3 minus 6, 3 plus 6, sorry, it is 9, minus 1 plus 4, it is 3, and 2 minus 3, it is minus 1. This is kind of the output in the first one. For the second one, he needs us to use the dot multiplication. So again, we are going to kind of having the 3 multiplied to 6, it will be 18. And then minus 1 multiplied to 4, it gives minus 4. And then 2 multiplied to minus 3, it's minus 6. So this is kind of the output in the element-wise, point by point. And we need to check that in MATLAB. Let's go to MATLAB and check what will be the output. If we go to the output here, this is the case for the case of vector and vector. So we have the vector v, which is equal to, and then we have 3 minus 1 and then 2. And we have the u vector with a value of 6 4 and minus 3. And if we said v plus u, and the second one is v dot multiply to u. And then let's run the section. If we check the output, it will be 3, 9, 3, minus 1, 18, minus 4, minus 6. This is as we expected to have the output for that. It's very straightforward, element by element. It's very easy. This is the output. And this is another example. It is kind of, we try to find more application in the real life. For example, in the following figures, it showed that precipitation data in 2018 and 2019, kind of the rainfall or precipitation over Tokyo. And it's required to estimate the percentage of increase or decrease of precipitation for each month between 2018 and 2019 using the following formula. So first of all, we have 2 years here, 2018 and 2019. And this is the monthly precipitation, for example, January, February, March, April, May, June, July, etc. to December. So we have 12 months. And for every month, we have 2 readings for the 2018 and 2019. And we need to know, is the precipitation increased or decreased? We need to know the precipitation, the percentage of that. And to estimate that, so the percentage, to estimate the percentage of increase or decrease, this is a very simple formula. It is the new value minus the old value divided by the old value multiplied to 100. For example, if we consider the January case, so in January, the percentage of increase or decrease for precipitation will be, the data in 2019, it will be like the 56, minus the data in 2018, which is 122, divided by 122. This multiplied to 100, we will have kind of reduction about 54%. So we need to do that for all other months. How to do that? Let's do that in like MATLAB. If we go to MATLAB, here's the example. The data for the year 2018 and 2019 is as follows. For example, in 2018, 122 January, 75 in February, 96 in March. So this data was written here. And also for the 2019, the data was written here. And we need to really just estimate the percentage of increase or decrease, which is equal to same formula, the new value minus old value to the old value. So we need to consider like the element by element. So this element to this element. So we need someone, so that as the numerator we have the plus or minus, it's better to use it. We must use the parentheses. So in that sense, we will say the y in 2019 minus the y divided by y in 2018 multiplied to 100. But we have error here. The error is for the vector to vector in the subtraction, we don't need to add dot. But for division, we must use the dot, so we put dot here. And then we will run the section to check the first value. And as we estimated the first value before, it was like the 54 something percentage. This is for the all other elements. So we can now estimate how is the percentage increase or decrease for the precipitation every month, something like that. This is the answer. And as you can see, I just showed the output with 2 decimals. So we can do that. As we mentioned before, we need to format, and this format will be bank. So we only have 2 output for the decimal point. And the next one is, what if we need to multiply matrix by matrix? So several rows and columns multiply to each other. And do you remember in the vector to vector case, we should have the same shape or same size or same number of rows or columns. Here is exactly the same. we should have same shape, same number of rows, and same number of columns. For example, if we consider A is 2 rows and 3 columns. B is 2 rows and 3 columns. And we need to do the arithmetic operation. So if we say that A plus B, so if we consider that it's element by element, so the first element here to the first element here, the second element here to the second element here. So for example, adding, so it will be A11 plus B11, and then A12 plus B12, etc. So it's element by element. This would be the same for plus and also minus, element by element, same element. And for multiplication, division, and the power, all the same, except that for the multiplication, division, and the power, we should dot, and then this operation. So to do like element by element operation, let's consider the example. For example, if we defined x as the 2 rows and 4 columns, and y 2 rows and 4 columns, so they have the same shape, same size, same dimension. And we said x plus y, so the first element here plus the first element here, 1 plus 7, it will be give 8. And if we check the last element here, it should be the last element plus the last element, I mean the second row, last column, second row, last column, 1 plus 8, it gives 9. So it is element by element. Again, for the x minus y, like that, it would be 1 minus 7, it would be minus 6, and then 3 minus 9, it would be minus 6. And for example, if we check the last element here, it would be 8 minus 1, it would be 7. For the multiplication, it is the same. We should use the dot multiply because this element by element wise. So if we check this element, which is the second row, third column, we should take second row, third column here, second row, third column here. It is 6 multiplied to 9, it is 54. And for the division, if we check the same place, so it will be 6 divided by 9. So 6 divided by 9, it is 0.667. And for the power, it is the same. If we check this position, it will be 6 to the power 9. We will have this output. Of course, I don't know like that. I can't remember the output for that. And let's practice. So here we have 2 matrices, x and y, and we need to write what will be the output in MATLAB for this, like the mathematical formula, if we need to do the element by element operation. So for example, what will be the output if we said y to the power x or y divided by x? So let's do that in MATLAB. We have x and we have y, and just we need y to the power x. So y to the power, but we need to remember that this is like the power, and the power should be have dot to the power and then x. And for the second one, which is y divided by x, it should be y divided by divided also should be, this is matrix, so it should be elements by elements. We should write dot divided by x. And then just run the section. We will have simply have the output for that. Let's check one element. For example, if we check the last output here, for example, this is 8 and this is 1. If we said 8 to the power 1, it should like that, sorry, 1, because this is y, 1 to the power 8, any 1 to any power, it will be 1, so the output here 1. And if we go to the y divided by x, which is like the 1 divided by 8, 1 divided by 8, the output will be like the 0.1250. Let's go to our presentation. This is the output. And this is the last section here. So the last section is how if we have vector multiplied to matrix. So we should have the one condition also here. So in the vector to vector case, we should have the same dimension. In the matrix to matrix, we should have the same dimension. In the vector to matrix, we should have the same number of row. So the condition, we should have same number of row here. And for example, if we have the A, it is 2 rows with 3 columns and B is 2 rows. If it's the same number of rows, we can do that. Why? Because if we said A plus B will be, we will take like B11 and add it to A11 and B21 added to A21. So this is the first element. And again repeat the same. So same column here will be added here. Again, B11 added to A12 and B21 added to A21. It's kind of, this column will be added here and then added here and then added here to this column. So if we said, how about A minus B, it's the same. We will take this column and like subtract this value or this B value from A1 and then the second one and then the third one. So it's kind of, we do that for column by column. So it is fixed column and then we subtracted that column from the old columns of the rows, of the matrix. And if we check like A multiplied to B, it should be dot multiply. So if we say that it will be A11 multiplied to B11, and for the second element, it will be A12 multiplied to B11, and then A13 multiplied to B11. It means that this element will multiply for all the element in the row, and this element multiplied to all the element here. It's the same as we did, we repeated this column for all the columns. And multiplication and division is the same. It is exactly the same except of the multiply or division. And for the power, we should use the dot power. And then every element here will have the power from that. So for example, this one will be to the power this, and here raised to the power and rise to that power. And again, for the second one, it's the same. We will have that one. So here, A11 to the power B11, A12 to the power B11, etc. Let's consider an example to understand. For example, if we have X 2 rows, 3 columns, and we have Y 2 rows, it is vector, have the same number of rows, which is 2 between the vector and matrix, it's okay. So if we say, for example, X plus Y, so for example, this 3 and 5, so it will be 1 plus 3, 4 plus 3, 4 plus 5. So 1 plus 3 is 4, and 4 plus 5 is 9. Again, 2 plus 3, it is 5, and 5 plus 5, it is 10. And then 3 plus 3, it is 6, and 6 plus 5, it is 11. So it's kind of repeating the same column for different column in the matrix. Again, for if we say X minus Y, let's consider the second column. So we will say 2 and 5 minus 3 minus 5. 2 minus 3 is minus 1. 5 minus 5 is 0. And for multiplication, if we use dot multiply or dot division or dot power, because this is vector with matrix. And if we consider the second column again, so it will be 2 multiplied to 3, it will be 6. 5 multiplied to 5, it will be 25. And then if we divide, so it will be like 2 divided by 3, it will be 0.667, and 5 divided by 5, the output will be 1. So the power is the last one. If we consider this one, so 2 to the power 3, it will be 8, and 5 to the power 5, it is 3125. Okay, let's consider the last example. We have X is a matrix 3 by 2, and we have Y is a column vector. And we need to write the following formula, which is X plus 2y and X divided by 2y, and we need to convert this mathematical formula to the MATLAB using considering the element by element operation. So X plus 2y, so the 2y is kind of the scalar multiplied to like the y is vector, to this scalar multiplied to vector, and X plus 2y is kind of matrix plus the vector. And for the second one, it is kind of X divided by 2y. 2y is still the scalar multiplied to vector, and X divided by y is matrix divided by scalar. Let's do that in MATLAB. Let's open MATLAB. And here we have the live script. So we have x and y, and we already defined x and y, so we just need to write the two formula. So the first one is x plus 2y, so we can write x and then plus, and then for the plus we don't need the dot, and we need to write 2 multiply 2, but this is scalar multiply 2 like the vector. We should use the dot? No, because the scalar to the vector we don't need, so it will be multiply to y. And then let's run the section. So now we have the output from the x plus 2y. For example, let's check the last element. So it will be x, which is 100, plus 2y, the y is 5, 2 multiply 5 is 10, so 100 plus 10, it will be 110. It's shown here, the last element. And if we check the second one, so it is x divided by 2y, so we can write x and then divided by, this is division, and in division we should use the dot, so dot divided, and then we should use the parentheses for the denominator, so we can write 2 multiply 2, and the y, the answer for the y, it's kind of the scalar to the vector, so we don't need to use the dot, and it will be just 2 multiply 2 y, and then run the section again. Yes, and we have the output. For example, here, if we have 100 and we have here 5, so 2 multiplied to 5 is 10, 100 divided by 5, it is 10, it is here the answer. So we can clearly understand the output from that. I think for today we finish. We just covered today like the how to multiply scalar to vector, scalar to matrix, vector to vector, matrix to matrix, vector to matrix. That's all for today. Thank you. Bye-bye.